Hi, so in this video, we are going to discuss about column distillation, the operation and principle of a distillation column, the structures and main components of a typical column distillation process, and the different types of column distillation, its operation, structure, column internals, and its application. So before discussing about column distillation, we must first understand what is distillation. So distillation is a process used to separate a mixture of two or more components into its virgin state by heating the mixture to a temperature between their respective boiling points. So distillation is a physical separation process and not a chemical reaction. So distillation may result in an essentially complete separation or nearly pure components are obtained, or it may be a partial separation that increases the concentration of selected components in the mixture. Examples of uses of distillation includes purification of alcohol, desalination, crude oil refining, and making liquefied gases from air. So the process of distillation begins with heating a liquid to a boiling point. The liquid evaporates, forming a vapor. The vapor is then cooled, usually by passing it through pipes or tubes at a lower temperature. The cooled vapor then condenses, forming a distillate. So distillation is based on the fact that the vapor of a boiling mixture will be richer in the components that have lower boiling points. Therefore, when this vapor is cooled and condensed, the condensate will contain more volatile components. At the same time, the original mixture will contain more of the less volatile material. So distillation columns are designed to achieve this separation efficiently. So what is a distillation column? So a distillation column is an essential item used in the distillation of liquid mixtures to separate the mixture into its component parts or fractions based on the differences in volatilities. The primary function of a distillation column is the separation of a feed stream into at least one top product stream and one bottom product stream. The quality of the separation performed by a column can be judged from the purity of the top and bottom product streams. So the specification of the impurity levels in the top and bottom streams and the degree of recovery of pure products set the criteria for a successful operation of a distillation column. So distillation columns are made up of several components, so each of which is either to transfer heat energy or enhance the material transfer. A typical distillation contains several major components. Firstly, we have the distillation column. It is a vertical shell where the separation of liquid components are carried out. A distillation column is a tube that provides surfaces on which condensations and vaporizations can occur before the gas enters the condenser. The next one is the column internals, such as trays, plates, and packings. So the column internals are used to enhance the component separation. The next one is the reboiler. So a reboiler provides the necessary vaporization for the distillation process. So reboilers are heat exchangers typically used to provide heat to the bottom of industrial distillation columns. They boil the liquid from the bottom of a distillation column to generate vapors, which are returned to the column to drive the distillation separation. And then the next one is a condenser. A condenser is used to cool and condense the vapor leaving the top of the column. The condenser is required to provide the cooling duty to condense the top product, which is partially refluxed back into the top of the column to increase the sharpness of the separation. And lastly, we have the reflux drum. So the reflux drum's function is to hold the condensed vapor from the top of the column so that the liquid or the reflux can be recycled back to the column. The next one would be the basic operation of a distillation column. So in a distillation column, the liquid mixture that is to be processed is known as the feed. It is introduced usually somewhere near the middle of the column to a tray known as the feed tray. So the feed tray divides the column into a top section and a bottom section, which are the enriching section and the stripping section respectively. So the feed flows down the column where it is collected at the bottom in the reboiler. Heat is supplied to the reboiler to generate vapor. The vapor raised in the reboiler is reintroduced into the unit at the bottom of the column. So the liquid removed from the reboiler is known as the bottom products, or simply bottoms or waste. So the vapor moves up the column, and as it exits the top of the unit, it is cooled by a condenser. So the condensed liquid is stored in a holding vessel, which is known as the reflux drum. Some of this liquid is recycled back to the column, and some of it are the distillate. So the condensed liquid that is removed from the system is known as the distillate or the top product. So there are many types of distillation columns. Each are designed to perform specific types of separation, and each design differs in terms of its complexity. Commonly, we have two major categories. We have the batch column distillation and the continuous column distillation. So first, batch distillation is an unsteady state operation. It is usually carried out in a batch still to which a column equivalent to a number of equilibrium stages is attached. Alternatively, packings may be used in a column distillation. So in batch operation, the feed to the column is introduced batch-wise. That is, the column is charged with a batch and then the distillation process is carried out. When the desired task is achieved, a next batch of feed is introduced. In the batch process, the main steps are operated discontinuously. So in contrast with the continuous process, a batch process does not deliver its product continuously but in a discrete manner. So this means that mass, temperature, concentration, and other properties vary with time. So batch processes are economical for small volumes, flexible in accommodating changes in product formulation, flexible in changing production rate, allow the use of standardized multi-purpose equipment for the production of a variety of products from the same plant. Best if equipment needs regular cleaning because of fouling or needs regular sterilization. Also, it allows better product integrity. The next category is continuous columns. So continuous column distillation, in contrast with batch distillation, it is a continuous feed stream. So no interruptions occur unless there is a problem with the column or surrounding process units. They are capable of handling high throughputs and are the most common of the two types. So continuous columns can be further classified according to the type of column internals. We have the trade columns and packed columns. So trade columns. Trade columns are used for making contact between a gas phase and a liquid phase so as to bring them as close as possible to the equilibrium state. Tray columns are widely used in various types of mass transfer operations. And yes, and a tray looks like this. So in trade columns, the trays are arranged one above the other, and liquid flows downwards the feed material, which is to be separated into fractions. It is introduced at one or more points along the column between the liquid and the vapor phases, between the stripping section and the enriching section. So the liquid runs down the column, cascading from tray to tray. That's why it's called a trade column, while the vapor goes up the column, contacting the liquid at each tray. So the next one is a packed column. So a packed column is a hollow vessel that is filled with the packing material. So packed columns are used for distillation, gas absorptions, and liquid-liquid extractions. In a packed column, instead of having trays, the units are packed with beds of metals or ceramic rings, or what we call as packings. So this is what this metal or ceramic rings look like. So these provides a large surface area within the volume of the column for the interaction between the liquid and gas vapor on entering the column. So a packing material, as shown in the screen, offers the advantage of a lower pressure drop across the column when compared to plates or trays. And this is beneficial while operating under a vacuum. So differently shaped packing materials have different surface mass and void spaces between the packings.
So the next type of distillation column is what we call the absorption and the stripper. Don't get confused between the two, because there are some equipments wherein they only use absorption and they only use stripper. But in this case, we use the combined equipment because it is commonly used. So what is an absorption column? Absorption column is an operation in which a gas mixture is contacted with a liquid for the purpose of preferentially dissolving one or more components of the gas mixture and to provide a solution of them in liquid form. The solute transfer is said to be absorbed by the liquid. It involves the diffusion of solute from the gas phase through a stagnant or non-diffusing liquid. So when we say diffusion, it is a process wherein a molecules will be subjected to from a higher concentration to a lower concentration. So the next type of distillation column is what we call the stripper column. Stripper column is a chemical equipment used for physical separation, where one or more components are removed from a liquid stream by a vapor stream. In industrial applications, the liquid and vapor stream can have a co-current and counter-current flows. Stripping works on the basis of mass transfer. So, above is the example of combination of absorption and stripper column in some petrochemical plants. The above absorption will have the product of rich oil, and that rich oil will serve as the feed of the stripper. The next type of distillation column is the fractionation column. Fractionation column is a type of still. It is to separate vaporized mixtures of liquid compounds with close volatility. There are three processes of fractionation column. First is the evaporation. Crude oil is heated until it evaporates. Crude oil vapor is put in the fractionating column at the bottom and rises upwards. Next process is the condensation. The temperature is highest at the bottom of the column. And the last is the collection. The fractions are then being collected. So, a simple still starts with mixed liquids such as alcohol and water produced by a fermenting grains. So, after boiling, it will produce a distillate in which the concentration of alcohol is many times higher than the feed. Crude oil is a typical feed for fractionation, and from it, the column can form simultaneously several distillates such as wax distillate, gas oil heating, naphtha, and fuel gas. And based on the nature of the feed that we have already discussed and the equipment's uses and functions, we can come up with a two things wherein we can classify them in two. First is the binary column distillation, and we can say that it is a binary column distillation if the separation technique used is to purify mixtures into their two separate components. Again, two separate components. While the multi-component column is a separation technique where it is only applied to three or two or more components or mixtures. So that will be all, and I hope that you learned something from us. Thank you and take care.